I'm going to mix up a blend of these two stains to be using on my owls here. So that's the last step to getting these owls set up. And so to do that, I'm trying to find a way to get the stain out of these cans without making a big mess. So I decided I need to make a 3D printed funnel that will not drip all over the edge of the cans, and I can mix them up over here in this container here once I get ready. So that's what I'm going to do, and that's what I want to show. Like other 3D printing ideas, it's an iterative process. I had a can that I used to use for dog food and stuff, so I adjusted this to see how it would fit, and that I fit so that it fits perfectly over the top there to keep it fresh. But what I really needed was one that would fit around this rim to keep the stuff from getting stuck in there and also act as a good funnel. So then the next thing I did was I printed this one to get the right size and test fit the size. And once I had that one test fitted, I went to this one. And then once that was there, then I could build the funnel on top of it, and that's what I ended up with, was this funnel. The funnel ended up looking like this. And let's go through that process. All right, to start the fusion design, I actually started with an earlier paint lid that I had in a file. And then I created a new component by hitting Create New Component. And so when I created the new component, I had to create a sketch. And so this was partly a sketch that was already here. And then I did the rest of the sketch. And the sketch for the outer lid said that the diameter of that lid was 73 millimeters. But when I measured that inside lip, it came out to be 56 millimeters. And that lip was the lip that I needed to cover up with the funnel part. And so that's where I started. Once I had that 56 millimeters, I had to figure out how wide I needed that lip to be. And it turned out to be 3 millimeters, so I put that in here. And then I went through the process of testing the various prints. And the first print I tested was a little thin ring and then a thicker ring. And so to get to that point, what I did initially, if I move forward down here, let's hit finish this. The first thing I did was I came in here and I created this ring. And the way I created that ring, if I do edit the feature here, you can see that what I did was I took that 56 millimeter internal part that I needed to fit around, and I extruded that out. And the first time I extruded it out a little about 5 millimeters to 10 millimeters. This eventually was 10 millimeters for later down the road. And once I did that, I had the ring that I'll put up here in the corner to fit into the can. And then once I knew that was going to work, I needed to move forward and I needed to make the actual funnel portion. So for the funnel portion, I created this sketch right here. And what I did was I created the sketch on top of the ring that was 10 millimeters high. So this part is 10 millimeters. The inside is 56 millimeters. And then I created a sketch on top of here. And once I created the sketch, I needed to do the funnel. And the way I did the funnel was I came in here and I extruded, and I'm going to edit this feature so you can see it. Edit feature. I extruded the top here out 50 millimeters. And when I extruded it out 50 millimeters, I wanted this design not to have to need any kind of supports on the printer. So that means it has to be less than a 45-degree angle. And I made this a minus taper angle of 25 degrees. So by making this 50 millimeters tall and minus 25 millimeters, I got this shape right here. So once I had that shape, I had the basic shape of the funnel. The next thing I did was I came in here and I put another sketch, and that sketch is going to be right on top of this funnel. So let me edit that sketch. And as you can see, I put that sketch right here on top of the funnel. And once I had that sketch, we'll finish the sketch here. The next thing I did was I took and I extruded, edit feature, I extruded that sketch out another 10 millimeters to get the edge, the end that I wanted. And once I had that, I went ahead and joined that to the rest of this funnel. And then I went ahead and I used the shell feature, which is this feature right here, up here. And to use the shell feature, all I did was, we'll edit it here. All I did was I selected this face right here, and I selected this face that was on the bottom. So there was a face on the bottom here and their face on the top, and you can see I have two selected faces. And I went ahead and put the inside thickness 3 millimeters, so that was a 3 millimeter thickness wall. And once I did that, then I had the shape of that I needed to with the right hole, and I was ready to go ahead and 3D print that. So I came up here to the 3D print feature, 3D print, grabbed that one. I made sure I grabbed that component right there and everything was blue. I hit OK. It opened up Bamboo Studio and I got this warning message. The 3MF is not from Bamboo Lab. Load geometry data only. Hit OK. Hit the file contains several objects positioned at multiple heights, and that's because there's multiple bodies in there. So I hit yes. And it came in just like this. And once it came in, I was all set to go. This came in pretty easy, and because of the draft angle, I don't have to worry about any supports. It's sitting flat on the bed there. All I had to do was go ahead and slice this. So I come over here to slice plate, and once I sliced it, I hit print plate, and then once I hit print plate, I hit send, and once I hit send, then it's over printing. And after I got it out of the printer, it worked out just perfect. Here's the funnel after it was printed. And then it fits right perfectly in this can. And because it's such a nice tight fit, this is going to be able to be poured into other cans and other places without getting gunk all in the can and without spilling the can over. If you've ever tried to pour out of these cans or other cans, you know how that lip can be a problem. So I'm really happy and glad it turned out just the way I wanted to. And to me, that is the coolest thing about having your 3D printer, is that you can adapt for special circumstances of things that you want. It just takes a little bit of ingenuity and design skills and learning how to use the software. And in this case, I've been using Fusion 360 and a couple 3D printers like those right over in the corner there. I printed that last one on that printer right there, which is an X1C. Printers I currently have is a P1S, which is this one over here, and an X1C. And if you want to know more about each of those and why I picked the ones I did, leave me a comment and I'll get back to you. Well, that's it, folks. I wasn't as detailed in my tutorial as I normally am in the Fusion portion, but I thought a quick run through might be helpful. And if you know Fusion already, I'm sure you followed it real quickly. If you don't know Fusion, hopefully you were able to still follow it. But I just love having my 3D printers and the ability to create things when I need them on the fly. That's a very helpful thing to have in your shop. And whether it's a woodworking project or something else, those 3D printers come in handy. And learning Fusion 360 is how I design my prints. If you would like a copy of this file, let me know in the comments, and I can post it to my website and make it available if there would be people interested. I would be posting the Fusion 360 file along with the STL, but I really find the Fusion 360 file to be of more use because then you can go in and make some subtle changes based on the can size that you're working with. Like I found out that between a Varathane can and a Minwax can, there was a little bit of differences in the size of that lip. So if you would like that, put that in the comment section. Let me know, and I'll get those put on my website. And in the interim, please go out and make some chips, have some fun, do a little bit of 3D printing, and you know what I need from you to keep the channel going. A like, subscribe, a comment is always helpful, and share this with others. Have a great day.